All right, let's do the first one. All right, so you have the scenarios right in front of you. Please don't write on them so that I can use them for my other class. The cost of a school banquet is $95 plus 15 for each person attending, okay? So the first thing that we're going to do is we're going to identify the independent variable. Okay, independent variable. I'm not asking for the 95. What is the independent variable? What depends on what? The what? Thank you. The cost depends on how many people are going. So which one is my independent variable? The number of people. Okay, hold on. All right, so the number of people. You have a paper in front of you. That's where you need to be writing it. On the white paper. All right. So the independent variable is how many people are going, which means the dependent variable is how much? It's the what? The cost. Very good. So the cost. Okay, children, how you put it in the notebook? How do you put it in the notebook? Like that. There you go. All right. Write an equation that gives the total cost as a function of the number of people attending. So what's my equation? There you go. 15x plus 95. So what's my rate of change? All right. So what is identify the rate of change? What's the rate of change? 15. Very good. It's 15 per $15, right? It's $15 per person. What's my starting point? 95. That's your y-intercept. What's my domain? There you go. It starts at, okay, what's domain? X or Y? What is X? The number of people. So it doesn't start at 95. From 0 all the way to what? To what? To infinity. Very good. Because it doesn't tell me if the banquet, if where they're held in has a maximum capacity, right? It does not tell me. All right, what about the range? It starts at 95 because even if nobody shows up, you still need to pay 95. And it goes all the way to what? To infinity. Very good. All right, so what is the cost of 77 people attending the banquet? How do I do this? You can plug it in or you can go to the table. Either way. All right, but I don't know if I want to go to the 77 right on the table. So you're going to say 15 times 77 plus 95. So how much would that be? 1,250? 1,250? All righty. Okay? All right. Now this is where you need to start writing on that paper, right? Are we good? Yeah, this. Yeah, all of that needed to be written just by the side because you don't have that info. All right. We're not using the calculator to graph the equation because this is something that I changed. We're not using the coordinate plate. And now, is the data continuous or discrete? You got to take a look at your x to decide. Is it continuous or is it discrete? It's discrete because you have to count the number of people that are going. Very good. So this would be discrete. You have to count. X is the number of people. You cannot cut people down. All right. The company decides to increase the flat fee charge to 125. Write an equation that gives the total cost as a function of the number of people attending. So talk to me. Y equals? What does Y equal to? Talk to me because I can't hear you. I'm wearing this. I can't hear you. 15x? Thank you. Plus 125, not 95, because they had just changed the flat fee to 125. All right, we're not sketching the graph. Identify the rate of change. Still 15, right? So is this line flatter, steeper, or the same than the other one? All right, say that again. All right, what was the other one? The other one was y equals 15x plus 95. So now talk to me, answer my question. Is this new line going to be steeper, flatter, or the same as this line? The same. How do you know? The rate of change is the same. Thank you very much. The rate of change is exactly the same. So it's not going to be steeper and it's not going to be flatter. Pay attention. Some of you should really be paying attention. We got 40s and 50s. What's the starting point? 125. All right. So what is the difference between this line and that line? Well, it's about 30 more. So what have I done with this graph? Moved it up. I have shifted up. Very good. It was on 95. Now it's on 125. Now, but I have not changed the slope, so it's not steeper. It's not flatter. It stays exactly the same. The incline stays the same. All right. Now let's define the domain for this one, for the new one. Thank you. Because the domain is the people. Now, only because it hasn't told me that there's a maximum capacity on the banquet of 300 people, right? It didn't tell me that, so I cannot assume. What about the range? Thank you. 125 to infinity, because now even if no people show up, they still charge me 125. All right, what is the cost for 7 people attending the banquet? So that would be 15 times what? 77 plus 125, which is just $30 more than the other one, right? So 1,280? Yay, because the other one was 1250? Yay? All right, so what type of transformation has occurred? You just told me because I asked you a few minutes ago. A shift up. Very good. How do we know that it has been shifted up? The y-intercept is what? It's higher. There you go. The y-intercept is higher. Are we good? You with me? All right. The company decides to keep the flat fee the same, but they're going to double the charge for each person attending the banquet. So write an equation that gives me this situation. So y equals what? 30x plus what? So 125 or 95? What was the original? 95, right? So how is this graph going to look? Flatter, steeper, the same? Steeper. How do you know? The rate of change has doubled. So now the line is going to be steeper because it's going to go up a lot faster because now it's 30 per people instead of 30. 15. All right. So identify the rate of change. What's the rate of change? 30. What's my starting point? 95. What's the domain? That doesn't change from 0 to infinity because we're talking about people. Now what about the range? From 95 to infinity, right? Oh, I'm sorry. This is supposed to be a parentheses, right? All right, what is the cost for 70 people? So what do we do? 30 times 77, right? Plus 95. 2,405? Yay? All right, so what type of transformation has occurred? Okay, the line became, I don't know how to spell steeper. Thank you. Thank you. I'm a horrible speller. How do you know? The slope has what? Did it double? The M, which is slope, right? Yeah, I try not to write too much, so instead of slope, I will always write M. The slope has doubled. Okay? All right, let's do the next one. Can we do the next one? All right, if I'm not mistaken, you probably will not have the space to do this one. Maybe yet, maybe, I don't know. All right. An airplane 300,000 feet above the ground begins descending at a rate of 2,000 feet per minute. Assume the plane continues at the same rate of descent. The plane's height and minutes above the ground are related to each other. So this is a function. That's what it means. All right, so let's write down an equation. You have the function, you have the situation right in front of you. So what does it say? What's my equation? You gotta use this. So what's the equation? So say that again. So 2,000x plus 30,000? Say it. Negative what? How do you know that it's negative 2,000? Because thank you, the airplane is descending. It's going down, so it's not positive 2,000. It is negative 2,000, okay? So y equals negative 2,000x. And then it had an initial height of 30,000 feet. Yes, sir. Yes. All right, what's my rate of change? Negative 2,000. What's my starting point? 30,000 feet. These are all feet, if I'm not mistaken. Is the data continuous or discrete? Continuous. Very good. It's talking about height. Can you measure the height? Yes, you can. So it would be continuous. This one is continuous. All right. What about the domain? What's the x? What's the domain? Let's figure out what x is. What is the domain? We first need to figure out what the domain is. Let's go back to an airplane 3,000 feet above the ground begins descending at a rate of 2,000 feet per minute. So what depends on what? So very good. The height or the altitude depends on how much time is passing. So what is my domain? No, minutes, which would be time, right? And then my range would be the height and that would be in feet, if I'm not mistaken. All right, so what's the domain? What's the domain? Yeah, it could be 0. 0 to what? 15? Is that what you said? How did you get that 15? Yeah, it's only the plane can only descend 30,000 feet, right? Very good. So, are you looking for your x or your y intercept over here? What are you looking for? X intercept or y intercept? To figure out what's the maximum time that this plane has. Stop talking. To figure out what's the maximum time that it will take that. I'm looking for the x-intercept. Very good. Where y equals 0. Which is basically what Ernesto said, taking that 30,000 and dividing it by negative 2,000. If I'm looking for my x-intercept, y equals 0. And then I get negative 2,000x. Uh-oh. I know. And then you can either go to equation solver, or you can take away 30,000 and then divide by negative 2,000. So he's correct. The domain would be from 0 to 15 minutes. A what? It's why it doesn't include 0? Does it include 0? You tell me, does it include 0? I can't hear because I got people talking. You don't want to be here, just go home, please. Karen, what was that? From 0 to 30,000? The range? The range would be the height, yes, and it's from 30,000 to 0 because that's the height needs to be 0, right? Otherwise, if it's negative, it crashed. It went underwater, right? So it would be from 0 to 30,000 because the range would be feet. All right, what is the height of the plane after 9.5 minutes? So what is it asking me to do? The x is 9.5. Thank you. The x is 9.5. So now I'm going to say negative 2,000 times 9.5 plus 30,000. 11,000 feet. Okay, so I need somebody to second that. 11,000. You don't even have a calculator out. All right. The pilot decides to decrease the amount of feet descended in each minute to half. What's the new equation? They decrease the amount of descent each minute to half the feet. Negative 1,000. X plus 30,000. What's the rate? What's the rate of change now? Negative, not 1,000, negative 1,000 because it's descending. What's the starting point? That hasn't changed. 30,000. What's the domain? Domain is the minutes. Ernesto, don't say it because I know you already have it. How do you get that 30? So now we're going to do 30,000 divided by negative 1,000, which would be 30. It's 30 minutes because it went from 2,000 feet to 1,000 feet. So from 0 to 30 minutes. What about the range? That hasn't changed, so it's 0 to 30,000. All right. What type of transformation has occurred? What's changing? The rate of change. It used to be 2,000. Now it's 1,000. So is it steeper or flatter? Flatter, because the slope went down. Very good. So line is it 2 T's? How do you know? Slope is what? Oh, the rate of change is half of what it used to be, right? Rate of change is half. Okay? Ready? All right. So now I need you to do this one as a group. Go.